What is up, weather enthusiasts? I'm your host, Pat's Path Predictor. Let's get right into the weather. Alright, so here's the situation we have for you, ladies and gentlemen. We have a lot to discuss with you today. We are looking at a potentially very big severe weather outbreak in the next few days. We had a day 7 15% risk a couple days ago that escalated to a day 6 30%. Now we have a day 5 30 and a day 6 15. So we're going to go ahead and be discussing all of that. We're also going to be looking at some of the parameters behind it, like what's driving it and what's potentially going to happen. Right now, it's a little too early to determine exact hazards and exact impacts, but by and large, by looking at the environment, we can be getting a general idea as to what we are looking at. And we'll go ahead and dive right into that in just a second. But before we do, we're going to go ahead and give you our storm code on this right here. This is produced by John, our head admin at Storms United. Shout out John for providing us with these maps. We have a hatched code yellow right now in effect for parts of Texas, Louisiana, Arkansas, and Mississippi. That's going to be shifted up further up to the north due to the 30% risk moving up there. But by and large, we are taking this very seriously. The only reason that we have not upgraded this to like code orange or code red or anything like that is because this is currently not an imminent threat, as John points out, and we should expect increases in the storm code level in future updates. This is mainly because this is so far out that we are highlighting it, but right now we're not escalating it behind up more than a hatched yellow until we get to day 4 or day 3 and all of that stuff. Once we get more data and information, that's when we'll bump the storm code up. But by and large, we have a hatched yellow out for this system right now. That's likely going to get increased and expanded further to the east into the Carolinas and those areas right here. But here's the situation that we have right here. We have a 30% risk from the Missouri, Illinois, Kentucky bypass area right here where the Mississippi and Ohio rivers intersect all the way down to north central Louisiana, and it pretty much encompasses the entire Mississippi River Valley right here, so the lower Mississippi River Valley right here, and we have a 15% from St. Louis all the way down to near New Orleans and Houston over here, and as far east as areas in Nashville points east, and even in Paducah and those areas as well, is in that 15% risk area as well. Mississippi, most of you is in a severe risk right here, but the 30 is in the northwestern half of the region right here. Arkansas, 2/3 of east of the state. Here's the day 6. We have a 15% risk for Georgia, South Carolina, North Carolina, Virginia, and the Delmarva Peninsula, as well as Maryland, D.C., New Jersey. Those areas, we're going to pay attention to that as well. That I am not as concerned about. It's this here that I'm concerned about, and we're going to have to pay attention to it. Let's go ahead and take a quick look at the discussion real quickly. Medium range guidance suggests that an initially zonal, intense mid to upper level jet across the western into central mid-latitude Pacific may undergo a considerable amplification into this period. What that generally means is that we're looking at potentially very strong trough that's going to be allowing the system and allowing the severe weather to go off. It remains a bit unclear how emerging waves will impact the downstream pattern. However, it still appears that one significant preceding shortwave trough migrating inland of the Pacific coast by early Monday will progress into and across the southern Rockies before accelerating east-northeastward through midweek. And guidance remains suggestive that this could be accompanied by strong surface cyclogenesis. That's how low-pressure systems develop. Perhaps most notably across portions of the east central Great Plains towards the lower Great Lakes region into the late Tuesday and Tuesday night. This may include an evolving warm sector with intensifying low-level and deep-layer shear in the presence of a southerly to southwesterly flow strengthening to 50 to 100 knots in the 800 to 500 millibar layer. 50 to 100 knots. They're already bringing numbers right here, and the numbers are very big right here. So we're going to have to pay attention to that. 50 to 100, yes, that is a bit of a wide range, but you could get a lot of severe weather with that. Especially if it, let's take the average and say it's 75 knots from 850 to 500. That is a lot of wind shear. That is a lot of speed shear. That is going to help your strength for your severe weather. That's going to help your strength for your supercells, and especially if it's down low, it gets closer to the surface. That's going to really help strengthen your tornado risk as well. So we'll have to see what happens with that. coincident with an influx of moistening and destabilizing boundary layer air off the northwestern Gulf. Yeah, that's going to be also a thing. There's going to be a lot of moisture coming up the Gulf of Mexico. We're going to have to pay attention to that as well. Spread typical at this extended time frame lingers along the various model outputs concerning that stuff, which may considerably impact the severe weather risk area and potential. However, the medium range guidance depicts an environment with at least conditionally supportive of an organized severe weather event, including for the potential for a few strong tornadoes and damaging straight line winds. We're going to have to pay attention to that as well, because they're already highlighting those hazards on day 5. You don't typically see that for a 30% risk this far out. You don't typically see a 30% risk at day 6. We're going to have to see how this pans out. We're going to have to pay attention to it right here, but that is what the SPC is going for at this current point. We're going to go ahead and take a look at some of the forecast models. We'll go ahead and pull that up right here. We're going to go ahead and use the GFS right here, mainly because this is the furthest it can go out. And we have the 12Z coming in, although it doesn't give us the full picture right here. Actually, it can give us the full picture a little bit. We're 5 days out. It can give us something that's going on right here. So let's go ahead and start 500 millibars and look at the wind speed. And what I'm going to be using with this map right here, we're going to be using this to look at the trough. We're going to be using this to look at certain features like, okay, what do we need to take a look at? What do we need to peer at in order to see what the hazards are? That's what we're going to be mainly doing right here. And I'll go ahead and move the screen over just so that way you guys can get a better view of the, stuff right here. So let's go ahead and take a quick gander at this. So here's what we have going on. We have our trough coming off the Pacific Ocean right here, and then it moves into parts of the Great Plains, including Texas, Oklahoma, Kansas, those areas right there. Look at how strong and look at how tilted this trough is right here. This is I believe this is a negatively tilted trough. This is slightly negatively tilted. If not, maybe it's neutrally tilted, but regardless of this, the strongest part of it is on the eastern side right here, and that trough is going to be moving in really quickly, and we're looking at wind speeds of over 100 knots across a lot of these areas. That's going to be moving into the severe risk, and that's going to be very concerning to say the very least with this trough, especially at this level where yes, you do see these kind of wind streaks right here, but for a severe weather event, you're going to want to watch these wind speeds. You're going to want to watch your right entrance and your left exit region. Your right entrance region is where you have your highest advection for cyclonic vorticity. That's where you have your highest chance for severe weather. And same with the left exit region. The right entrance region, if we go ahead and cut this into 4s right here, your right entrance region is where I am moving this cursor right here. Your left exit region is where I am rotating this cursor right here. That's the general gist of it. I know I'm getting into more technical stuff with the dynamics of it and all that stuff. Shout out to my professors for teaching me all of this. I really appreciate that. But by and large, looking at the synoptic setup of this, the jet strengthens even further as it's approaching. Like, we're looking at wind speeds of up to 120 knots extensively across Texas, Louisiana, Arkansas, Mississippi. This is a very powerful trough, and this is going to be a very big severe weather setup right here, and that you can bet your bottom dollar this is going to advect a lot of moisture up as well. Let's go ahead and move down to 850. Look at the wind speeds. 850 wind speeds are pretty interesting, to say the very least. Yes, you have your low pressure system. Yeah, it's going to, how this is going to end up happening based on recent modeling is it's going to develop as a Colorado low, but I don't think you're going to, I'm going to check this just to make sure, but I don't think you're going to see that much snowfall. This is going to be more of a rain event and maybe snow on the backside if you're in the Great Plains, but this is going to be a mainly severe weather type system instead of a snow system like we were seeing the last couple of months. And this is probably going to be our first big severe weather outbreak of the season if it does pan out the way it is expected to. Here's what we're looking at by 21Z. We're looking at wind speeds up to past 75 knots at 850, according to the GFS run right here. That is insanely concerning, to say the very least. And I do want to take a couple soundings. I want to take a sounding out. I actually want to take a 12Z sounding out of Louisiana right here, and I want to take another one out of around the Memphis area in Tennessee. I just want to take a quick gander at those just to kind of see what we're potentially looking at for an environment setup. Okay. So 12Z, okay, this is the thing I'm looking at right here. Do you see this yellow and this red barb right here? Those are your wind barbs. Okay, moved into the wrong thing. I'll go ahead and zoom in on this just to show you what I am looking at. This is your directional shear, and this is your speed shear right here. You're looking at surface to 1 kilometer shear of 36 knots. That is a lot. At 12Z, mind you. This is not even when the severe weather system is expected to start. 36 knots at 1 kilometer, that is easily going to enhance your tornado development. Right there. Surface to 6 kilometers, 60 knots. That is quite crazy, and that's going to enhance your supercell development right there. I just figured I'd show you that just to kind of give you an idea of what I'm looking at and why I am taking this so seriously. Let's go ahead and take a look at what we're looking at in around the Memphis area. 36 knots surface to 1 kilometer. That's going to enhance your tornado development later in the day. I know it says none right here. That's mainly because there's a strong cap right here, and this is in the morning, mind you. Surface to 6 kilometer, 44 knots may not be as favorable for supercells, but by and large, shear-wise, you're looking at a very good environment for tornadoes. Let's go ahead and go to 21Z and pluck a sounding, one out of Tennessee and another one out of central Mississippi right here. I want to take a quick gander at this stuff just to kind of see what's going on. Okay, your shear really ramps up. You're looking at 46 knots of wind shear and 73 at 6 kilometers. That is unbelievable right there. I have not seen values that high since March 31st. Now, granted, this is the GFS. This is very early. I want to preface this, but the projected soundings are showing a lot of wind shear, and this, in my opinion, is going to be a very shear-driven event. And if you're going to see a severe weather outbreak, this is why. You're looking at almost 50 knots of wind shear at 1 kilometer. Look at this SRH. 848. That is well past extreme levels of SRH. That's shear relative helicity for context right there. And shear relative helicity, what that typically does, it's generally spin, and it gives you just shows you how favorable the environment is. There's a lot of math that goes into it. I'm not going to get into it, obviously. You probably just want to know what the severe weather threat is. But I am showing you guys these soundings to show you just how much potential this system has. 73 knots at 6 kilometers. That is pretty interesting. Now, I just want to check real quickly what the precip is looking like. I want to look at the simulated reflectivity. Okay. That's interesting. 21Z is probably not the best to do that then. I'll take a couple more soundings before the projected stuff is going on. But by and large, 46 knots. That's pretty interesting to say the very least. We're gonna have to see how this pans out, but yeah, this is gonna be quite the day for severe weather. We're gonna have to see how this pans out. Now we'll have to look at other parameters as well. I'm gonna go ahead and go back to 850 real quickly with the wind speed just to show you. This shear really is ripping right here. And you need to pay very close attention if you are in a lot of these areas, because this is a very conducive setup for severe weather right here. And I am not trolling by this. This is, now granted, this is just one run. I can also show you the GMGDPS. It's not showing as strong of a scenario right here, but we'll have to see how this pans out, and we'll get more information in the next day or so. Okay, this is the 0Z. Here's the 12Z. The 12Z is coming out, but it's not all the way out. Similar with the GFS. We at least can give you a general idea of what's going on. Granted, I am recording this at like 9:30 in the morning, so that's part of the reason, but still, take this very seriously. This is going to be very shear driven. Look at the trough too. This is going to be negatively tilted. Looking at the surface, I do want to take a quick gander at this. I want to take a look at surface temperatures as well as dew points and anomalies and all that stuff, just to kind of show you how this is going to advect and how this is going to pan out. Let's go ahead and go to the southeastern U.S. right here. Let's go ahead and show you what we have pulled up right here. So yeah, we do have a bit of a cold snap that goes into parts of the region right here, but then you start to see a lot of warm air advection right here. You start to see a lot of that warm air start to really move through, especially starting on Monday. Because before on Sunday you had temperatures increasing to the low 60s in a lot of Mississippi, Alabama, upper 50s in upper parts of those states. But on Monday, you see those temperatures warm up to the mid 60s in a lot of Louisiana, Mississippi. In fact, the GFS was looking at temperatures around 80 degrees in isolated areas of Louisiana. I'm not 100% sure if it's going to be that warm. I'm going to check the European. Yeah, the European's about 10 degrees cooler with those isolated areas, but still, you're looking at upper 60s compared to lower 60s the day before. And then on Tuesday, you're looking at a lot of stuff happening. You're looking at a lot of temperatures increasing to the mid 70s. Here's your dew point temps. Your dew point is going to be very intriguing, and it's going to be very critical to what type of severe weather we're going to get. Your dew point temps at the surface, you're looking at dew point temperatures in the lower to mid 60s with this. That is going to be a lot of dew point, especially in this part of the South right here. This is like a dew point of 60 degrees in a like around 72, 73, 74 degree Fahrenheit temperature environment. That is a lot of moisture. And relative humidity, yeah, you're going to see a relative humidity in the 80s. It is going to be very buggy and very muggy that day before the severe weather hits. Typically, when you think of a severe weather day, you typically think of the day before all the storms start to develop. You think of it as a very sticky, very hot, very humid, very muggy type of day. One of those days that just doesn't feel quite right. It seems perfect, but except for all the temperature and all that stuff, the sun is out, it's all nice and all that stuff. But then, bam, late afternoon, you start seeing convection firing off. You're gonna see that in these parts of the South right here, given what I have so far. But by and large, it's a lot of stuff to pay attention to. Let's go ahead and also take a look at the kind of the early projections. I want to take a look at the surface-based CAPE. Potentially as potential. I know it's not going to be particularly accurate. I personally think you're going to see a lot higher values as we get the more mid-range runs like the NAM and the GEM RDPS in range. But ultimately, you are seeing CAPE values early on looking at cracking around 1,000 joules per kilogram. That may not seem like a lot, but you have to remember two things. Number one, this is a highly sheared environment. That's number one. You don't need, in a highly sheared environment, you don't need a lot of CAPE, or you don't need a lot of convective available potential energy, mind you, to get a result if you have the shear to do it. An infamous example of this was actually the 1965 Palm Sunday outbreak, where you didn't have very much CAPE. You had around 1,400 joules per kilogram max, but the shear was cranked up to well over 100 knots at bulk shear, like 0 to 6 kilometer was over 100 knots, and it ultimately just was more than enough to allow for all those EF4s and those F4s, F3 tornadoes to really ravage through Michigan, Indiana, Ohio, all those states right there. It's actually still Indiana's worst tornado outbreak in their history, but ultimately, that's the kind of stuff we're looking at. That's number one. Number two, in this part, like geographically speaking, you don't need a lot of CAPE. You don't need a lot of energy to really get severe weather going. If you're seeing a day in the Deep South where you're looking at like maybe 2,000 joules per kilogram, that's equivalent to about 3,500 joules per kilogram of CAPE in an area like Texas and Oklahoma and Kansas and those areas. It's the same dynamics and all that stuff, but in the Deep South, because you have the Gulf of the Gulf going on, and you have the Gulf advecting a lot of moist air, it's not going to need as much CAPE to really generate a result. And taking a look at your supercell composite, 4 days out is pretty big. You're looking at a supercell composite up to 10 already in a lot of these areas right here. You're looking at a highly high potential for a supercell type of event initially, and then it's going to start transitioning more into your typical squall line setup, and ultimately it's going to become more of a straight line threat. But I do think in the mid to late afternoon, you have a very high probability of supercells and discrete cells. That is going to be a very big problem. So that's going to be your tornado producer, and then over time they're going to evolve into a squall line, and then move into parts of the other parts of the South, like Georgia and the Carolinas and Virginia, and all those areas too. All that is a bit arbitrary. It is a little early. I do want to make that clear. But by and large, based on the environment I am seeing right now, this is something we should all be very concerned about, and we'll continue to update you here on the Pat's Path Predictor channel. But with that being said, we're going to go ahead and close the video out right here. I really hope you enjoyed it. Be sure to leave a like and subscribe to the channel if you are new. It helps us out, helps us get more people engaged with weather. If you want to come hang out with us at Storms United, if you want to ask us questions about this severe weather threat, be sure to join the Storms United Discord server. We've been talking about this extensively. I've been talking to John about it. We've been going back and forth before I recorded this video. So be sure to join the Discord server. The link is in the end screen. Also, shout out to Daniel as an official sponsor of the Pat's Path Predictor channel. Join the Patreon to be that. It's in the first link in the description down below. With that being said, have a wonderful day, guys. Stay safe.